Hello, how are you? This is the Ethereum developer course of the Morphosis Swarm and for the Wild Hive community. And today is the lecture 3. We are going to be looking at Hardhat tooling. The Hardhat is a Ethereum developer tool that allow you to do a lot of things in a smart contract environment and lets you be really efficient with your time and with the amount of things that you can accomplish in a smart contract environment. This is a quite new tooling with the latest advances in the in the last 1 year or so that allow to be much more efficient, as I say, and accomplish much more with less time. So to start, what we are gonna do is I prepare this Hardhat demo example, and this had a few. It has a simple Hardhat project that allow us to start doing stuff and configurations and learn while we practice it. So I have it open here in Gitpod. I just start the project, and what is done is installing my dependencies, and now I'm able now to use Hardhat with npx Hardhat, and this will show us what Hardhats provide us. So first of all, we will see that we have the Hardhat version, this version installed, and this is showing us how the Hardhat command work. So the Hardhat will allow us to pass global options, provide a task, and the task options. And to give a bit of context, Hardhat is this tooling that allows us to create tasks to do several things and also run different scripts or run our tests all in the same environment. So, but yeah, tasks are one of the main ways that Hardhat allow to configure and provide value to us. So then to go out really quick through the global options, we have a few things to configure how Hardhat behave, but the most important that we need to focus on is the network that allow us to select which network we are really running Hardhat with. Then we have a list of all the available tasks, and most of these are tasks that came as default in Hardhat, so are like the every task here except the account and generate are the default task that Hardhat comes with, and these other two are the ones that we create for the example. And from these tasks, the most used or important to start getting attention is the compile that will allow us to compile code into our environment from our contract. Then we also be using the console to check things that allow us to review more in detail what is happening using a console. Then we will have this other one that is really important, the node. That is, this allow us to run the Hardhat network. That is a local network that we barely use in the last couple of lectures, but we're going to be doing much more with it in the next lecture and today. And this task in particular is also starting a JSON RPC server on top of this local network, so we can communicate. And if you remember, the JSON RPC was this low-level protocol that communicates with the Ethereum nodes to send message in this syntax. So we can ask the node things, and the node will return us using this protocol. So this task start a JSON RPC server to communicate with the local Hardhat network. Finally, the other two that are important are the last ones that are the run that allow us to run specific scripts to do things in our environment, like for example, deploy a contract or verify a contract, all of that is probably a good fit for a script. And finally, a test, run our tests that are also running with this test and using Mocha, that is a test environment. And we'll probably focus much more in this test in the next lecture. But these are like the default tasks that we have available now, and most of them. And then we have this other that we will be seeing next. So, step page. So to continue, this directory, what we have is an example of a test, an example of an script, and a simple contract that we are gonna start using to test things. And then I have configure a simple VS Code configuration to allow us to debug more in detail in that we are gonna be seeing next. And then the other important file that we have to look at is the Hardhat config.json. And this is where Hardhat will be configured to be more fit for us. So as we can see here, we have here the two custom tasks that we define. One is these accounts that we are going to use next, and this generate task. But let's keep them here and let's focus on other things that we have here. Then we have this an example function and a method and a variable. And then we have this module export that is here where we will be configuring the whole Hardhat configuration. So this is one of the most important things that we should take into account to have our environment set up correctly. So what we can configure here. First of all, we are seeing this default network. This will be like the network that is going to be used by default for Hardhat. So in our case, we are choosing Hardhat, but this is actually the default that Hardhat does. So if we don't put this here and just leave it without, leave it like this is going to be the same as here. But if we decide to choose other default network, then we can state it here. So okay. So we have default network, and if we want to use other network, we will say, I don't know, mainnet, and we will change for that. But first, we need to define that. So to continue, this other configuration we have here is the Solidity compiler. So what we are saying here is that we are going to be using the Solidity version 0.7.3. This is the compiler version of our that we are going to be using on our environment. And that is going to depend on the contract that we are going to be writing and compiling. And here we can see that we are using Pragma Solidity at least 7. So we need to have at least a compiler with a 7 to be compatible with our contract. But definitely here we can choose other ones, and we are going to be seeing more on that. But to give a quick example of how that might work, we are going to be running we are running here a compilation task, and let's see what's happening. So here what we will do, Hardhat is going to be downloading first our compiler version. This is really a really great feature that we get on top of Hardhat without any more configuration. Otherwise, we will need to handle what compiler we will want to use, and we might need to download binaries ourselves, and that was a lot more complicated in previous toolings. But here we have this handled automatically for us, depending on this. So if, for example, we change to compiler version, the next BAM version, the download, Hardhat will download the new version and compile the code with this one instead. And then we will be, and in next succeeding compilations, this step is not going to be happening. And in this case, as we didn't change anything in the contract. But for example, if we change deploying for deploying and we compile again, then we only be doing the compilation and not the whole. So to give also a bit of context of what is that, what this compilation task is doing. If you remember in Remix or even in ETH build, we were doing also more manual compilation and we were seeing the output that we were getting from that. But in here, that information is stored in this artifacts folder. So if you look, these two cache and artifact folders were generated by Hardhat, and inside this Hardhat is gonna be all the information we need about compilation. So we have here, for example, the contracts, and inside here we will have a couple of files. These are probably things that Hardhat does for the console, for example, and we will see it later. And build information, probably that we are mostly not gonna be using this in our case much, but this one, the contracts greeter.sol, that is our smart contract. We will be having here the greeter.json that we will have all the artifact information we want. So for example, we will have the ABI once again, we will have the bytecode, we will have more contextual data that might be useful for us, like the contract name, the source, what is the source, where is the path of the source, and yeah, all this is gonna be used by other libraries that we are gonna be using in a more high level language now. So this Solidity configuration that Hardhat provides has even more, can be configured even more, and we can be, for example, be more specific here with the settings that we want to provide. For example, we can be doing that we want to runs, I think it is. We want to, yeah, let me check just in case that I'm not having the right. Yeah, for example, here we will have a more complex configuration as an example. So if we use that configuration instead, oh, I couldn't. I didn't grant access to this website. Let me check. How is that? Let me see if this works. Okay, not sure why it's not allowing me to paste, but no worries. Okay, we have like settings and optimizer here. So what we will be able to be more even configure a bit more our compiler. For example, here we will do a few configurations that allow the compiler to be configuring a specific settings that we will be learning later on, but are more advanced. But yeah, it's just to say that you are able to have more configurations, and even you can be having more than one compiler version. I think in, for example, this recent project that we were having, we were configuring a few versions of Solidity. For example, if you want to be having more than one compiler, you can be like compilers and pass an array of compilers. For example, here we will have this version of the compiler and this other version with this configuration. This allows us to have contracts with more than one setting. For example, if we have this contract and we have a new contract with 0.5, then we can have both and compile them all at once. So yeah, to continue this, let's leave the simple setting that we had with the version 0.7.3, I think it was. And let's I think one other thing that I want to include here is yeah, I'm probably, maybe it's better for me to start working on the on my local machine because I have some configuration that allow it to be more efficient. So I'm gonna keep working on this. That is the same by my local machine. So here yeah, we have the default configuration with for Solidity. And to continue showing what our configuration we have, for example, here we can also configure the networks that we will be connecting to. So here we can start writing a network configuration. And here we will have two kinds of network. The Hardhat network, that is the local network that allow that Hardhat providers. And then we have also JSON RPC based networks. And this will be like all the usual network that we know, like mainnet, we will have Rinkeby, we can have XDAI. All this will be possible to be configured with this setup. And then we'll have the Hardhat network, that is the particular network that Hardhat give us with a specific settings. So here we'll be having this different configuration for each of us. Let's put only mainnet and XDAI for now. And what this network can be configured with a lot of configurations that we will be seeing in the, and I will be sharing this documentation, but you have a lot of ways to configure it. So here we have this Hardhat network configuration that has all these values that can be configured to be more specific about it. And then we have the JSON RPC based network that we'll be configuring as well as much as we can. But for now, let's focus only on the URL, that is where this provider that we have been using, the node that we're using. And for that, let's use the one, for example, you can get one from Infura or for Alchemy. And in here, I'm gonna get one of these that I have. And these are like the endpoints that we can use for the different networks. And in this case, I'm gonna just use this one. And for XDAI, let's use it, the one that the XDAI, in the XDAI website we have here in the development resources, we can get a few JSON RPC endpoints to connect. So we can connect now to the XDAI one. And then the other thing so here we will have already a connection to these networks. But the other thing that we want to have is, as we were seeing in previous lecture, is having a keeper and having a way to sign. So for that, we'll be handling this other accounts configuration. And as you will see more in detail when you read the documentation, here are how they are explained. Here, this explanation of how this network works, how this account configuration works. But for example, you can configure it like this. For example, you can pass an array of private keys. If you have, like, for example, your private key 00 or your other private key, those will be the ones that are gonna be used in the for this network. But what we are gonna do is use one of the tasks that we have here. This is the generation task. You don't need to understand everything that is happening here, but what this task allow us is to generate a mnemonic. So the mnemonic is a advanced keeper that we use in the if build as well. So what we will do is run this task. So npx hardhat generate, and this will generate for us a mnemonic in this in our environment. So now we will have this mnemonic phrase that we can start using as our keeper in this network, for example. So we will define this mnemonic, and we have this mnemonic function defined here that we will be handling this mnemonic for us. So let's do the same for the XDAI network. So now we have both a network configured in mainnet and a network configured in XDAI. So finally, yeah, for the Hardhat network, let's leave it as the defaults. So now to give you an example of how that works, let's use these other tasks that we have, like the account task, that what it does is printing all the accounts we have available for the mnemonic that we are using. So, or the accounts that we have actually defined here. In this case, it's a mnemonic, but if we have a array of private keys, that will be the ones used. So let's first use the default Hardhat account, and this is gonna be, as you can remember, we are gonna be using the default network if we don't give a network value here. So what will happen is that this is gonna be using the Hardhat network by default. And one thing to note here is that every time that a task or a script or a test is run with the that is run without being a JSON in a JSON-based network, then automatically Hardhat will run the Hardhat network for us to have to use to interact with the network. So in this case, what is going to happen is that the Hardhat network is gonna be run first, and then the task is gonna be run. It's gonna be run. So in this case, if we run this, what will happen is that all these accounts are gonna be printed. But what are these accounts? These are not the one that we define in this mnemonic. These are the default accounts that Hardhat network gives us. So if we go to the Hardhat network, I will be sharing this documentation as well, but we will see that there is a initial Hardhat network state that the Hardhat network has. And for generating this state, the default mnemonic that the Hardhat network is using is this one. And it's generating the same accounts that we are seeing printed. No, we have like 0xf, 3nf, and all that. But now, if we also run, for example, accounts network, and we give the mainnet network, then we are going to be having other set of accounts connected and being able to be used. And these accounts are going to be the ones generated from these mnemonics. The same is going to be happening if we are doing for XDAI, but of course, these accounts are not going to be having any amount of ether because there were no initializing these networks. But in the case of Hardhat, these are accounts with 10,000 ETH because Hardhat set up that in that way, so we can have an easy way to test our things. But and yeah, that was everything I have to say on that. And then to continue, the other configuration that is not much relevant is this pass that is usually not used a lot. But what allows us to do is choose where are the different default path to be used. For example, where are the cache is going to be stored, where the artifacts are going to be stored, where the sources or the contracts are going to be stored. So all this is going to be can be also configured. For example, we can say that instead of leave cache in the cache, like the default, like we are seeing here, we can say I want to store it in, I don't know, cache root cache, and then there will be stored in other folder. So all this is to doing that configuration, but the defaults are generally the way to go here. So yeah, let me see what can we continue with. Okay, let's now explain a bit better about the Hardhat network that we will be using a lot. So as we will see in the when we run the Hardhat the Hardhat help. Oh, hard, hard, there is something. Oh yeah, this is imported without. I'm not sure why that got imported automatically, but yeah, that was getting an error. But yeah, what I was going to say is that as we saw, we have also this node task that we can use. So let's go ahead and run that. And this will be running as the task described. This will be running both the Hardhat network and also a JSON RPC server on top, so we can interact with it. So at this point, we have this Hardhat network running, and we'll be able to interact with it and see what is happening. And also, we will have this endpoint at this URL to be able to communicate with it. And to do that, also Hardhat give us this other JSON RPC network as default that is called localhost. That the only thing that one of the default configuration that it has is that it has this URL with the default server endpoint that Hardhat network with the node task run. So this is usually defined as default, but we can be explicit here and leave it so we can understand a bit better how this works under the hood. So now every time for example, if we run the same task that we were running before, but with the local host here, we will be having the same accounts that the Hardhat has, because we are connected to the Hardhat network, as we will see. So this is usually the way that we will be interacting if we want to see what the Hardhat network is doing. For example, here we saw that we are sending this JSON RPC message. We are asking for the accounts. We are getting the chain ID as well for that request. And yeah, this will be really useful to see more in detail what is happening under the hood. So yeah, to continue now, to give you a bit more of details of how the Hardhat does all this, we will be talking about the Hardhat runtime environment. And I think the best way to explain it is that Hardhat runtime environment is everything that we are seeing that we are using, like tasks and networks and providers. All that will be packing in this Hardhat runtime network, and it will be exposed for us everywhere that we are using the Hardhat. For example, every time we are running nps Hardhat test, or every time we are run a script, or every time we are Hardhat console, or everything that we are doing, probably we will have also the Hardhat runtime environment available for us. And to give you an example of that, I'm gonna be looking into this script more in detail, or we can look at the test. Yeah, maybe the test to make it. Yeah, for example, in this test, this is a simple test that is checking something in our contract that is not relevant now. But what I wanted to to showcase is that here we don't have anything defined except that this chai import. But if we connect to using this launch configuration on VS Code, we will be connecting the process of for to do things and debug more in detail what is happening under the hood. So here we will be connecting to the test Hardhat test. So one thing that we need to configure is where is the Hardhat executable libs. In this case, it's in the node modules binary Hardhat. And then we'll be giving the argument that we are going to be using. So this configuration is going to be the same as we were running Hardhat test. But we will be doing in this way, so VS Code provide all the debugging functionality that we want to use now. So let's go ahead, go to the debug tab, select the Hardhat test process, and let's run it. So as we can see that this is connecting to the process and stop here. That I put a breakpoint here to check it out, what is happening now, and what are the things that we are seeing in this at this point. So now we have we have the terminal here that we were using, and we also have this debug console that allow us to see things that are happening now. So if we see here, we have a few things in the screen. We have here variables that are defined. We have watch that we can create to look. We have the call stack. This will be all the things that are run or that were run at some point in this process. So, but what is really cool here is that we can start seeing what are the things that are going to be happening here. For example, if we go one step ahead, then we will have let's put other breakpoint here, for example. And what we will happen is that this line is going to be run, and now we can see what this variable has in the information. But yeah, this is really cool in itself. But what I wanted to showcase here is what other global variables we have this in our disposal. And if you can see, there are a lot of things that probably we have in every node application, or even in any context. But one of the things that is relevant for us now is this Hardhat runtime environment at HRA. And let's print it here in the console so we can see it in more detail. So we will see here that we have this Hardhat runtime environment that if we open it up, it has all these things defined. So, and this is injected by Hardhat for us to use in this test. So we will have access to all this in our test, just because we are running the test with Hardhat. And this is really powerful because allow us to get access to all the tasks that we have defined, allow us to have access to run scripts that we were using with the run, allow us to have access to the specific network that we are using. In this case, is the Hardhat network. Allow us to have access to other things, like in this case, the ethers library, because we have it defined in one of the configurations, but we will see this more in details. Allow us to have the artifacts that were compiled, and we have it now in here for us to access, for example, bytecode information, or the ABI if we want to use it. And yeah, all that is really powerful, and this is what the Hardhat runtime environment is doing for us, injecting all this configuration in the test. Or even if we now, let's finish this, but if we now run, for example, the run script, the sample script, this, and let's put a breakpoint here and run it, we will see that as well we will have this Hardhat runtime environment available as well. And this means that we can use all this as well in our script. And that's why that's what the Hardhat runtime environment does for us. Okay. Now to continue, let's talk a bit about, let me see, what else? Cool. Yeah, now we can look a bit more into the Hardhat network with a few examples. So yeah, first of all, to give a bit of context of how the Hardhat network is different from a node, an actual node, is that it the default behavior is that every time we send a transaction, it mines a block. So for example, if we run the script, the sample script here, and this script, what it does, to give you a bit of context, is just deploying a deploying a contract and just imprinting the address of that new contract. And you don't need to worry about how this is done with ethers, because we are not gonna be seeing this now. We are probably doing that in the next lecture, but that's what this script does. It's just a deployment for us. And sorry that I forgot to include the network localhost, because we don't want to use the default Hardhat as the default behavior. We want to actually connect to the localhost Hardhat network that we are running. As you remember, we need to provide the network localhost global configuration here. So what we just did is deploy this new contract, and now we can see that this is the output that we are getting from the transaction we just sent. And as we can see, the Hardhat network give us a lot of context of what is happening, giving us what is the actual contract that is deployed, the name of the contract, give us the new address that is generated, as we can see here. Give us the transaction hash, give us the from address that is deploying this contract, give us how much gas it used, and what is the block number that is done. But if we run it again, we're gonna be seeing that this new deployment is now in the next block. So every time we are sending a transaction, the Hardhat network by default is mining a new block, and that's a configuration that can be also changed. If you see here, we have a lot of configuration that we can alter. But yeah, this is probably something that I'm gonna share for you to look more in detail. Then this other thing that we can look here is that we have this console log deploying a greeter with greeting hello Hardhat. What this is also an advanced, not advanced, but a really impressive feature of the Hardhat network. And what it allows us is to print console logs during the execution of code in the Hardhat network. So how we doing that? We use this import Hardhat console.sol. This is an actual Solidity code that we get from the Hardhat library, and then we will be using it as any console log that we will usually do in JavaScript, and this is gonna be executed during the execution. For example, here we will see that when we are constructing this contract during the deployment, we are printing this, deploying greeter with greeting and providing the greeting message that we are sending in the constructor. And that's why we are doing here, deploying a greeter with greeting, hello Hardhat. And that's what we define in the sample script here, that the deployed argument is going to be hello Hardhat. And that's what is printed in here. And this is really powerful because allow us to be really have a lot of power into seeing what's happening. No? So now, to continue to showcase other of the features of the Hardhat network, other really cool feature is the stack traces that allow us to understand what's happening under the hood with the for example, some errors that we might have. So for example, here, if we run the Hardhat test with the network, we are running the test in our local network, and as we can see, this is doing a few contract calls and sending a transaction to do things in the contract. And probably, as we can see in the test, this is calling the greet function and then setting a new greeting instead of hello world, setting it to hola mundo. And these are the two functions that we are calling. These are the call for the greet. And this is a transaction that we are sending to the set greeting. So in here, we can see that we are also getting a new console log that is changing the greeting from hello world to hola mundo, and that's how we are getting that printed. But now what we will be doing now is adding a condition with required and putting an impossible condition, like one different of one, and we put a message of impossible condition. So now this is always gonna be failing, of course, but what we want to show now is what is happening in this case. So this is gonna be doing a lot of things. As you can see, first of all, it's gonna be compiling the code again because we changed the smart contract. Then it's gonna be running the test, and of course, the first if call is gonna be doing right. But then when we are sending a transaction, this transaction is gonna be revert because it's saying the virtual machine couldn't execute this code, and it's giving a revert reason like impossible condition that we define here. But the cool thing about this is all this extra contextual information we're getting, that this is usually what we call stack traces, and we are getting a lot more help on where the specific error is happening. So in this case, we are getting a recognized contract. In this case, it's not showing specifically. I wonder why. Unrecognized contract. Let me check if we deploy now once again. Yeah, now I'm not sure why it didn't recognize the previous one, but now that we get the right one, yeah, now that the contract is actually recognized by this set greeting function that we are calling, now we are able to see be more specific of how the whole stack trace is happening. And the really interesting part in general is the last step in the stack trace that is actually given us the contextual place in the smart contract that this error is happening. So as we can see, is this contract reader that's sold in the line 20. And as we can see, we can go here and say, oh, okay, this is an impossible condition. We can remove it and everything will be working once again. And that's really powerful as well and is saving a lot of time when you are running your test and checking that everything is working as you expect to be working. And yeah, that's in general really cool. So yeah, to continue on a few other things about the Hardhat network, and this is something that you can also check more in detail, but I would like to show how the JSON RPC method that we support in the Hardhat network, and all the usual methods that you expect to be supported are supported. And also there is other really interesting methods that allow to usually helpful to test things and to debug. So for example, we have ways to impersonate accounts, we have ways to increase time, we have ways to mine, to revert, or to create snapshots of specific things. And all those are in general useful for writing tests or create or specific things that we want to do. For example, impersonate an account is really useful if you are doing mainnet forks. That is other great functionality of the Hardhat network that we are going to be seeing next. So yeah, to continue with this and doing a good segue, let's configure a bit the Hardhat network to fork other blockchain. So the Hardhat network configuration that we didn't change so far allowed to have this other forking feature that allow us to fork a particular blockchain that we want. No? So this functionality is really useful because allow you to, for example, in some cases that now that there is a lot of complexity in the existing smart contracts that are already deployed in the different blockchains. So if you, for example, wanted to test something in your particular protocol that is interacting with whatever DeFi existing tool, like Compound, for example, then you're going to be needing to deploy the whole Compound architecture and contracts in your local machine, in the local network, to be able to test that specific things that you want. So that's why this forking feature was invented to allow you to not have to do that work, that extra work. Instead, we can take like a snapshot or in this case, it's called like fork the existing network in a particular block after a particular block, and then run the code that we want to run on top of that and on top of that stage. So for doing that, we'll be also providing a URL for the node that we are going to be connecting. And in this case, there is a caveat that is going to be explained in the mainnet forking documentation. But this is that you are usually want to provide a archive node. These are a particular kind of node that has a lot of more of contextual context and information about everything that happened in the blockchain so far. So in this case, we are going to be using the XDAI archive node that we have at our disposition. And then the other thing that we are probably want to state is the block number where you are going to be forking the blockchain. So let's get the block number, and usually, as is advised in the documentation, you want to at least leave a few blocks to so the information is much more is not having some synchronization problem. For example, in here we can say instead of the 5, put a 3 to be a bit earlier in the chain. So now we are forking the XDAI network from this point, so from this block number. So let's close our existing chain and let's run it again. And what we are doing now is running the Hardhat with a fork of XDAI from sign this point. So this is really powerful feature and give a lot of a lot of potential value and use case to have. So for example, we can do an interesting test. For example, we can look into some address in the existing blockchain, signs that block because we want to be sure is we are correct. But for example, we can check some of this address, for example, this address, and we can check that it has at least 0.25 DAI. So we can copy this and we can ask, for example, to console this. Let's comment this so we don't, but let's, yeah, we have at our disposal the Hardhat network. So let's do ethers to get utils, I think it was get balance. Yeah, let's do it more network that provider that request, and we will be sending a request to the provider. And let's check the JSON RPC to get balance of the specific get balance. So we need to provide the method get balance. let me double check if this is correct. I think I have this done in one example, and also we are going to be using this other one that I want to show you. So let's leave this here. So we will be having, yeah, request method param. Okay, cool. So let's do this. So we are sending a request to the network, to the provider, in this case the Hardhat network, and we are going to be sending the, instead of this method, we want to send the if get balance of this, and also we are going to be sending first, it's going to be the address of the account, and then it's going to be the block number, if I'm not mistaken. Yeah, the latest in this case. That in this case, latest is going to mean the one that we define in our configuration, because it's the last one that we. So if we console.log and let's put balance equal, and we might want to do, yeah, balance. Yeah, we are gonna be running this. Let's do run script network localhost. Oh yeah, sorry. We might want to comment this for now. Yeah, method. Network provider request method. Oh, my bad. I did write that wrong. The method is get balance, and we want to provide the 2 parameter here. That was my mistake. So now invalid value latest supposedly. Oh, other error here. And the address is also in parentheses. So now we have it. Yeah, we call the get balance, and we are getting this huge hexadecimal. So let's do hex to decimal converter. And now if we put this here, we'll have like this really big number. So 35 seems like 35 index die, where the amount of die that this address has at this point. So if we check, yeah, he has a lot of transfers, but yeah, that's just to showcase how we can check that this that we are actually in the right network. But the other thing that is really cool is this other, for example, this other method that we have available for in the Hardhat network, that is the impersonate address. So we can call the Hardhat impersonate account, and we will have access to this account. So at this point, so for example, if we do a signer, and we will do impersonate address, and we will call it, oh, let's store this address, but we will say we can impersonate this address. So now we will have our disposal this, and instead of we will be deploying, let's do this deployment, but instead by this address. So how we do that, we are doing the Ether sketch factory, but now with the greeter, we will be connect to this signer. So what we're doing here is, first of all, impersonating this address. So we'll be using this address as our own in the Hardhat network, and then we'll be deploying this contract using that address. So that's useful sometimes when you want to actually do something or test something with some kind of account that you might need permission in the actual network, but you want to try if all the steps involved in your test or in your deployment or whatever are actually happening. So now when we run the script, what will be happening is, oh yeah, sorry, this is still with a syntax of uh, TypeScript instead. But now, yeah, everything seems to work as expected because the contract was actually deployed. But what is really interesting is that we are actually using this address instead, that any, we didn't have the private keys actually to do this, to do a signature per itself. But as we have this method particular of the Hardhat network, we are able to sign a message with this and then actually send in this case, a transaction. And also we are able to send a transaction because it's an address that has XDAI at that point. So we can actually pay for that execution. And yeah, that was everything about the Hardhat network that I had. Now, to continue, I would like to give a few explanations about, yeah, a quick overview of the Hardhat console. So now we have the console, and if we connect to the local host, we will be using this console connecting to this local host network. And what is the console is a really easy and useful way to try things quickly and check things. For example, as you expect, here we also have the Hardhat runtime environment for us to use with every data that it has. We will be also able to run awaits inside here in the console. So we will be able to do the same request that we were doing before, like await, HER, like network, like request, and send whatever request we want here. We can even say, ethers, and here we can also get inline completion of all the things that we can call in ethers. For example, we can say providers that get, I don't know, let's see what we can call here, but yeah, we can say, for example, ethers get signers, and that will print all the signers that we have available into this network. So this the console is really useful for all those things that we want to do things really quickly and test things in the so yeah, this is there is a lot of good things to do with the console, but and yeah, remember that you can also connect to mainnet or to XDAI, and that's gonna be using the console in that network context. So yeah, to continue, I would like to talk a bit about the Hardhat runner. That is the things that we are actually already seeing, like running scripts and running tasks, are the two main things that we Hardhat provide us to run or specific things that like we are seeing here, like as deployment, and in this case we are adding some impersonation of an address. But then if you want to be more with adding more complex things, like for example here we create a generation of a mnemonic manually, or in this case if we are run and print all the accounts that we have available. But yeah, then you will be running creating a task And a task, yeah, I'll be also sharing the specific documentation of how to do it. But a task is a more complex thing that you can even provide parameters and give a much more rich contextual work done with a task. And that's what Hardhat does with the Hardhat default tasks, like the compile or the node. All that are tasks that Hardhat define inside their library. But you can also create as complex tasks as those and use it in your environment. So to do a segue to that, then Hardhat, the final great feature of Hardhat are plugins, and that's a way to extend the functionality of Hardhat, reusing existing work done of other developers. And that's a really easy way to keep adding things into the Hardhat runtime environment that are helpful for improve our code and our flow of work. Those are installed as dependencies. For example, here we already have two of them that are like the default ones that are usually really encouraged to use. For example, the ethers one and the waffle. Ethers is the high-level language that abstract a lot of things that we have seen so far and make it really easy for us to code in a more high-level language. And we will be seeing in detail in the next lecture. And Waffle is other library that help with test, providing a lot of functionality on top of that. That is really nice to have. But we can have a lot more of these plugins that will be, and these are all in this plugin documentation, and there are a lot of them done by the Hardhat team, the Nomic Lives team, and but you can also have a lot of interesting ones done by external developers. And to show you how easy and useful that may be, we will be installing two of them, these two by Chris Wicken. The first of them is the solidity coverage. So what we will be doing is running installing this. And let's, first of all, let's check the documentation. This has a few comments on how to install them and configure it. And in this case, it just run the installation to install the dependency, require them in the configuration file, and just run that. So let's add, first of all, the solidity coverage as dependency. This will be adding the dev dependency for us in the package JSON. And the second requirement is to require solidity coverage because we are using GAs instead of TypeScripts. So let's add that into our Hardhat configuration file. And that's all that we need. Now we will be having a new task that is implemented by this plugin, the coverage task, that will be handling the coverage of smart contract code for us. So let's do that, and let's run just Hardhat coverage now that we have it configured. And let's also run it into the network localhost to see what is done for us. So first of all, I think we need to run it with the default because otherwise we need a more complex configuration. But yeah, first of all, let's see what it does. First of all, we can see that is doing some instrumentation of the coverage. This is all that is handled by the plugin. Then it's doing the compilation, but because we are nothing to compile, it's not compiling. And then it's also running our test and is adding all the coverage data. And the coverage is a way to measure how much of our code is actually covered by our test. And all that information is right in the coverage and the coverage JSON files. And if we can see If we go to the file that is where is our coverage, we can see we have the Hardhat demo, we have the coverage here, and if we open this file, we will see that we have all this data with information about the coverage, and we will be seeing this a bit more in detail next week. But what it provides us is really powerful for just adding a line of code and installing a dependency, and everything is already set up for us to tap into that functionality. So to give a second example, let's install also the other plugin of the Hardhat gas reporter. And as we can see in the documentation, there is also installing the dependency and require the tooling. So we will have, first of all, let's install the dependency, and then let's require the new installation. And as we can see, there is no new task, but instead we can add a few configurations in a few new configurations in the gas reporter section. And in this case, we can see that this is a tip that advises to maybe configure in these ways to enable or disable the report of gas for our tests. So we are gonna be following that advice and configure it in our configuration here. So what we are doing here is enabling this gas reporter if a report gas environment variable is included. So what we will be doing is adding a script that is gonna do the test with gas, and what it's gonna be doing is we're gonna be adding tests with gas, and we are gonna be running yarn, yes, npx hardhat test, but what we are gonna be adding is the report gas value equal to true. So every time we run the test we run this script with the test gas, then we are getting the report of gas. So now we can have out tests, no tests. So we will have test. So now when we run yarn test gas, that's how we run this script. We are gonna be running npx hardhat test, but we are also passing this report gas through. So that's how the gas reporter knows that we want to use the reporter. So what we are just seeing is that this is also compiling our files, is running our test, and then is doing some calculations to get the information about how much gas each method is taking. For example, when we are calling the set greetings that is updating the greeting, we are spending this amount of gas, and when we are deploying the actual contract, we are spending this amount of gas. So now we can, for example, update the greeting and remove this console log, for example, and run this measure again. And we are probably seeing an improvement of the gas use. Let's see. And yeah, as we expected, both the set greeting is getting much, a bit more less expensive to call, and the deployment of the actual contract is getting a lot less expensive. So this is also a great tooling for us to improve our solid implementation and make it more efficient, and getting a lot more context of what is happening during our development of the code. And that was everything that I have for today. And